Hi everybody. The purpose of this video is to introduce the concept of limits. With a limit, we are usually asking for what is my f of x doing as x approaches some value. Put more formally, what is f of x as x approaches some value that we will call a? When we talk about a limit, I want you to think in your head of expectation. And you'll see why in just a minute. Let's go to our coronavirus data. This is the data for the number of cases in the United States since the start of the pandemic. And today is August 19th, 2020. Suppose we wanted to ask, how many confirmed COVID-19 cases do we expect on August 20th? We could use the data from the 16th, 17th, 18th, 19th, and make an estimate for the 20th. And if we wanted to write that using the formal limit notation, we could write, what is the limit as x goes to August 20th, 2020, of the number of COVID cases? Usually, we don't talk about limits in the context of data like this, so let's go over and look at some of the functions we've been working with this semester. Let's go ahead and graph our f of x. And what I want to ask is, what is the limit of f of x as x approaches 5? And I'm going to put that nice dot on there, that point, so that we can see clearly. And I want to know, what is my f of x as x gets near to 5. So as my x increases and gets closer and closer and closer to 5, what is my y? Notice I'm looking at both sides. I'm looking from the left-hand side of 5 and from the right-hand side. In order to determine whether or not we have a limit and what that limit is, we need to find the limit from both the left-hand side and the right-hand side. All right. So one of the ways that we can find this limit is we could eyeball it and look at it graphically, or we could find values that are close to 5 and figure out what our f of x is likely to be. Or we could use some algebraic skills. Right now, we're going to focus on the numerical. So I'm going to make a table where I have x in one column, and I'm going to have f of x in the other column. And I want to pick values close to 5, but on the left-hand side. So that's smaller than 5. So why don't I start with 4.9, then 4.99. 4.999. And I'm going to keep on getting closer and closer. And what I want you to notice is that my values stop changing so much. They stabilize. So see that? We have 4 decimal places that have not changed by the time I get really close to 5. So what I can say from this is the limit of f of x as x approaches 5 from the left-hand side is 5.099. Now let's go ahead and look from the right-hand side. I want to start bigger than 5, so I'm going to choose 5.1. And then I'm going to get closer to 5. Notice that I choose to either increase or decrease by an order of magnitude. Okay, that's just to keep it all really easy, and so I don't have to think that much. And it will also converge quicker if we do that as well. All right, and now we see that we have 4 decimal places that have stopped moving. It's kind of arbitrary that I'm choosing 4 decimal places. You can choose 3, but you want to go far enough that it's clear that the values of f of x have stabilized. Another word that we call this is converged. So what we can say here is the limit of f of x as x approaches 5 from the right-hand side is 5.099. Now, because my left-hand limit is equal to my right-hand limit, I can say that the limit of f of x as x approaches 5 is 5.099. So I have a limit, and it is 5.099. So this is a fairly simple function, and it probably doesn't come as a surprise to you what that value is. And what's important to recognize is that the limit has nothing to do with the function value. It's just what we were to expect if we were to keep on going along that path. So let's look at another example which doesn't have the function existing at that point. This is my g of x. Now notice that the function does not exist when x is equal to 0 because you can't have a 0 in the denominator. And I'm going to ask, what is the limit of g of x as x approaches 0 from the right-hand side? I can't ask, what is the limit of g of x as x approaches 0? Because I don't have the function existing on the left-hand side. So this is all that I can ask. I'm going to go ahead and make a table. And I'm going to make sure that in my second column, I specify that I'm looking at g of x. So when I'm doing these tables, I'm really asking, what is this doing as this goes to a certain value? As we go along in our calculus journey, we will stop using functions right here and start using other expressions. But it's always the same idea. What is this doing as this is approaching a value? So let's go ahead and pick a value close to 0. I'm going to choose 0.1. And I'm going to keep getting closer and closer by an order of magnitude each time. And notice that, ooh, yikes. Notice that I am never putting in 0. I can't put in the value. I can only get close to it. And what you see is as I get closer and closer and closer to 0, that my limit of my function as x approaches 0 from the right-hand side is -8. Okay. So let's look at one final function. Let's look at the function h of x. So h of x is a piecewise function that looks like cosine of x when x is less than 0, sine of x when x is greater than 0, and -1 when x is equal to 0. So if I'm eyeballing this, a limit does not exist because my limit from my left-hand side is 1. My limit from the right-hand side is 0. Even though the function does not exist at those points, that's what the limit is. -1 from the left-hand side, 0 from the right-hand side. There we go. And the actual value at x equals 0 is irrelevant. So the limit of h of x as x approaches 0 from the left-hand side is 0. But nope, it's 1. The limit of h of x as x approaches 0 from the right-hand side is 0. Therefore, since they're not equal to each other, the limit of h of x as x approaches 0 does not exist. The other situation we might run into is if we have a vertical asymptote. If you have a vertical asymptote and you're trying to find the limit as x gets near where there is a vertical asymptote, then you might find that your limit is infinity or negative infinity. The important thing to know here is if you're looking at the limit from the left-hand side or the right-hand side, you can have a limit as infinity or negative infinity. But if you're looking for a limit, in that case, a limit does not exist. Even if you have a function that goes off to infinity on the left-hand side and off to infinity on the right-hand side, the limit there still does not exist because you can't have infinity equal to infinity. We are going to continue to work with limits, and some of the changes that we're going to be making is instead of looking at the function value here, we are going to be looking at either the slope of a line between 2 points or the area of a bunch of rectangles. And we are going to use this limit idea to ask what is happening to this value as our input is changing, or as our input is getting close to a value. So the limit is a concept that exists broadly, and we will use it to build the definition of our derivative and the definition of our integral shortly.